Okay, last video, and hopefully this one will be a little shorter than the others because we don't have far to go. Okay, activity 4. So we are going to explore the relationship between triangles that have the same angle measures but side lengths that are different. So for the first thing that they want us to do is list the corresponding angles and sides in the two triangles. So actually on the next page, they're going to tell us that corresponding parts are angles or sides that match up between two shapes. So we're going to start by listing the angles because those are a little easier to pick out. So I can see that angle R in the first triangle is congruent to angle C in the second triangle. So angle R and angle C would be called corresponding angles. I can see that angle Q in the first triangle and angle B in the second triangle are corresponding angles because they both have a measure of 48 degrees. And last, I can see that angle P in the first triangle and angle A in the second triangle both have measures of 15 degrees, so they are corresponding angles. Now notice that when I wrote my corresponding angles, I have all of the angles from the larger triangle on the left side and all of the angles from the smaller triangle on the right side. So it's important that we keep our lists organized, and the order in which we list these corresponding parts is important. So now I'm going to move on to the corresponding sides. So the corresponding sides don't have the same measure, obviously, because we have a bigger triangle and a smaller triangle, but there are still sides that match up. So I'm going to start with the big triangle, and the side at the top that is 6 units, I'm going to refer to that as side QR. So side QR using line segment notation. And now I have to find the side in the smaller triangle that is corresponding. So side QR is the one that went from the 48-degree angle to the 117-degree angle. So in the smaller triangle, from 48 degrees to 117 degrees, just to help me navigate, would be side BC. And I want to make sure that I have the letters in the same order. So from 48 degrees to 117 degrees. So QR and BC, corresponding sides. Back to the larger triangle. So side RP along the left side is going to be corresponding with side CA in the smaller triangle. And I know that because those sides go from 117 degrees down to 15 degrees, again, if I'm using those angles to help me navigate around the triangles. The last pair of corresponding sides would be side QP, or I could call it side PQ, but depending on how I name that one, I have to name the side in the smaller triangle the same way. So if I call it side QP in the larger triangle, I have to call it side BA in the smaller triangle. If I were to reverse the letters and call it side PQ, then I have to reverse the letters in the smaller triangle and call it side AB. So we're pretty picky about our corresponding angles and sides and the order in which we list things. So the next question is for us to describe how these triangles are similar and how they are different. So I think it's pretty obvious that the triangles have the same shape. And I know they have the same shape because the corresponding, remember that means matching, so corresponding angle measures are the same. As far as how are they different, well, they obviously are different sizes. So the triangles are different sizes. We've got a bigger one and a smaller one, and we can tell from the side lengths. So we'll just note that the side lengths are different. And you might notice something about the side lengths. More on that to come. Okay, so number 12, as promised, what do you notice about the lengths of the sides of the two triangles? If I scroll back up real quick and we look at those two triangles, not sure if anybody noticed, if we look at the corresponding sides, that 18 in the larger triangle and 6 in the smaller triangle are corresponding sides, and in the smaller triangle the measure is 1/3 of what it is in the larger triangle. And if I check the other corresponding sides, that same relationship holds true. So 6 in the larger triangle, 1/3 of that would be 2 in the smaller triangle. And of course, 21 in the larger triangle is 7 in the smaller triangle. So 1/3 of the measure of the side in the larger triangle. So we want to answer number 12 by noting that relationship we just saw. So I notice the side lengths in triangle ABC are 1/3 of the side lengths in triangle PQR. And this brings us to the last page. So on the last page, 38, we've got two terms. So similar figures, definition is figures that have the same shape but are not necessarily the same size. The sides are proportional, so we just said that all of the sides in the smaller triangle are 1/3 of the sides in the larger triangle. Or we could have said the sides of the larger triangle are 3 times the size of the sides in the smaller triangle. So sides are proportional and the angles are congruent. So remember the angles were the same in both triangles. So I'm going to draw an example here. I'm just going to make a real obvious, just a sketch. Whoops, that wasn't so great. And I'm going to put a right angle down here in the bottom left corner. I'm going to call this triangle A, B, C. I'm going to put a single arc up here in angle B and a double arc over here in angle C. And I'm going to draw a larger version of that triangle. Try to get it a little bit better. Okay, not as bad. And I'm going to call this triangle DEF with a right angle down there in angle D, a single arc up here in angle E, and a double arc angle F. And now I can say for the symbolic representation that triangle ABC is similar to triangle DEF. So this symbol I used translates to the words is similar to. And just like we've been talking about, the angles have the same measure. A and D are both 90 degrees. B and E, we don't know their measure, but because they each have a single arc, we know that they're congruent. And C and F don't know their measure, but because they have a double arc, we know that they're congruent. So these are similar figures. Same shape, different sizes. The corresponding parts we had some experience with on the previous page. We're going to go ahead and practice listing the corresponding parts for these two triangles. So we will start with the angles. And I can say that angle A and angle D are corresponding because they're both right angles. I can say that angle B and angle E are corresponding angles because they both have a single arc. They are congruent. And I can say the same for angle C and angle F. Now for the sides, remember, especially when I list the sides, I have to pay attention to the order. So I'm going to say that side AB and side DE are corresponding. So those are the sides that are between the 90-degree angle and the angle with the single arc. I'm going to say that side AC and side DF are corresponding. Those are the sides between the 90-degree angle and the angle with the double arc. And last, side BC and side EF are corresponding. Those are the sides across from the right angle. Again, I have the sides and the angles from the little triangle on the left. I have the sides and the angles from the larger triangle on the right. So just like it says in the definition, the order of the matching matters. We always want to pay special attention to that. Okay, so the last couple of things we need to do are to fill in the blanks to make the statement true. And this kind of goes back to when we were taking the rectangle and the triangle and making it bigger, making it smaller. If the change in dimensions of a shape to a new shape has a scale factor of 4, so that means we've multiplied the side lengths by 4, then the change in the shape's perimeter would be a scale factor of 4. So remember, if I double the side lengths, I'm going to double the perimeter. So if the perimeter is times 4, then the side lengths are times 4. Those will always match. Number 14, if the change in dimensions of a shape to a new shape has a scale factor of 7, then the change in the shape's area would be a scale factor of. So if they had asked about perimeter, it would be a scale factor of 7. But for the area, we're actually going to take that scale factor and we're going to square it. So we're going to multiply it by itself. 7 times 7 is 49. So that means the new image would have an area 49 times the original. Remember, when we double the side lengths, the area quadruples. 2 squared is 4. When we triple the side lengths, the area increases by a factor of 9. So 3 squared is 9. For number 15, if the change in perimeter of a shape to a new shape has a scale factor of 49, then the change in the shape's dimensions would be a scale factor of. So if the perimeter has a scale factor of 49, then the dimensions would match and also have a scale factor of 49. So the side lengths change at the same rate as the perimeter, vice versa. Number 16, last one. If the change in area of a shape to a new shape has a scale factor of 36, so now we're talking about the area, then the change in the shape's dimensions would be a scale factor of. So we don't want to multiply 36 times itself. We want to figure out what number was multiplied by itself to get 36. And of course, that would be 6 times 6. So that means if the dimensions had a scale factor of 6, 6 times the original, then the area would be 36 times the original, 6 squared, or 6 times 6. So these are things that we will talk more about when I'm back on Thursday. In the meantime, make sure you get all of the notes copied into your module for lesson 6.2a. So go back and fill in anything that maybe you missed. And the homework assignments for today are actually review for our quiz, which is next Monday. So you're going to have a review worksheet on section 6.0 using a protractor, ruler, classifying, and you'll be doing the section 6.1 review from the homework packet, which goes over the triangle inequality theorem and some other things about triangles that we learned in section 6.1. So notes for 6.2a lesson are complete, and now you've got 2 homework assignments to work on that are due on Thursday. I will be in school tomorrow before school and during CAT and after school if you need to come see me about anything. Otherwise, I will see you on Thursday.